All right, let's take a look at number 5. So on number 5, our parent function is just the line y equals x. So y equals x looks like this. The slope is 1, so that's why I'm going up 1 over 1, up 1 over 1. And if you go back to the equation over here, you can add a plus 0 to see that the y-intercept is 0. So that's why I started right here. All right, so this is probably enough points right there. So this is going to be a graph of our parent function. Now, what we want to do is we want to know what transformations are going to happen to that if we look at the function negative 3x plus 6. So why don't we start off with the negative out front, okay? Negatives in front of functions mean that we are going to reflect over the x axis, okay? So I'm going to go ahead and take all these points and reflect them over the x axis. 3 spaces, 3 spaces, etc. 4 spaces, 4 spaces. And that's enough for us to see at least what this is going to look like. So let me go ahead and just draw it. So that's actually going to be y equals negative x. All right. So let's take care of, I'm going in order of R, S, T, reflect, stretch or shrink, and translate. Remember, there is an order of operations here. Okay, so now let's go ahead and take, sorry, that arrow isn't really clear, but it's pointing to the 3. So if you multiply a function by 3 out front, then you're going to be stretching it vertically. Okay. So that means, and I'm looking at the red one, that means that I'm going to take all of the y coordinates for the ordered pairs. So let me just grab a couple. Let me grab these 4 red ones right here. So we have 1, negative 1, 2, negative 2, 3, negative 3, and 4, negative 4. Well, what we're going to do, since we're stretching it, is we are going to multiply all of the y coordinates because we're going vertically. If it had been horizontally, we would have done it to the x coordinates. So we're going to multiply them all by 3. So I'm going to keep all of my x's the same. All right, so if I multiply by negative 1 by 3, by 3, I get negative 3. Negative 2 by 3, I get negative 6. And you know what? We're going to be off our chart here on these other ones, okay? So I might also just take 0, 0, 0. So if we multiply the y coordinate by 3, it's still going to be 0, 0. So this point's going to stay. 1, negative 3, 2, negative 6, and that's the last one on our chart. Okay, you could probably see that it'd be 1, negative 1, positive 3, and negative 2, positive 6 to stay on the same line. So let me go ahead and draw a line through that. Okay, so that's going to be our graph stretched by a factor of 3. What I like to look at is I like to say, okay, well, this was 1, but then if I go all the way to the point at the same x value, that's 3 long. So you can see we really did stretch it by a factor of 3. Okay. All right, so now we're going to take the last transformation, the plus 6. So adding a 6 to the back end, well, that's going to move it vertically, right? And this is the one that tells the truth, right? So since it's vertical, it's telling us the truth, which means it really is going to go up 6. Okay, so we're going to take our points and we're going to shift them up 6. So I'm going to start with 0, 0. It's going to go all the way up here, 6 spaces. This one's going to go up 3 and then 3 more. So there's 6. And this one's going to go up 6. So our final graph, which I'm going to draw solid, is going to be this one right here. Okay, so I'm going to go ahead and label that h of x. Now, this is kind of silly to graph this way because we already know how to graph lines and stuff. So if we went old school and we said, okay, well, +6 would be the y-intercept, and it does go through +6. And then -3/1 would be the slope. So I'd go down 3/1, down 3/1. Then we can see through the old lens, so the old way of looking at it, that we do indeed get the same line as looking through it in this new way. So let's go and put in our answers into MyLab Math. So we started off with the parent function y equals x. We stretched it by a factor, vertically by a factor of 3. So we had to multiply each y coordinate by 3. Then we reflected across the x-axis, and then we shifted it up 6 units. All right. That's a lot of drop-down menus to pick from, huh? All right. So hopefully, let's see, we need to graph it ourselves. Okay, so let's go ahead and graph it ourselves. So we're gonna pick the line. We know that we went through 6. I can see in the upper right corner, it does say 0, 6. And then we went down 3/1. All right, so hopefully this helps you with number 5. That was actually kind of a tough one. All right, thanks for joining me, guys.